Hey folks, welcome back to another video. Today we're looking at question 300, longest increasing subsequence. And the way we'll be approaching this problem is by using dynamic programming. So the basis of dynamic programming is that it looks at the solutions that you've come up with previously for smaller problems and build on top of that. So let's walk through an example. So the example that we have right here, for example 2 is 0, 1, 0, 3, 2, 3. Right? So this is a DP array, right? And you initialize that to be all ones. And the reason why you initialize that to be all ones is because it's of size 6, which is the same size as the given input array to us. And then what it's saying right now initially is that even if we don't go through the array, we know at least that an element by itself can form the longest increasing subsequence. So that is just the base case, right? So you start off with a DP array just filled with 1, right? And you look at all of the subarrays. You start with just 1 element, and then you start with 2, and then 3 and 4, and you keep increasing that. So the reason why you're doing that is because you're looking at the previous elements that you have seen to check if you can build on the previous solution that you got, which is the basis of dynamic programming. So let's get started. It's a lot easier to understand with an example, right? So we look at 0, and this is the first element, and there's nothing before that, right? So just by itself, it'll be 1, so you don't really do anything in the first case. And then we increase 1 more element, right? And what you're doing here is that you're looking at 1, and you're looking at the previous element, right? And you know that the previous element is smaller than the current element. Therefore, the corresponding index will look at the previous solution, which is 1, and add 1 to that. So this becomes your array. Your DP array has just looked at something in the previous index and seen that, hey, you know what? This array together makes a longest increasing subsequence of 2. Therefore, this becomes 2. And then what you do is you add 1 more element. You're telling, hey, you know what? Let me look at a subarray of size 3, right? So you look at 0, and you look at all the previous elements. None of the elements are less than 0. So this index right here, right, the 1, because there's nothing smaller than 0 before that, it just stays as is. And then you add 1 more element, 3. So you see that it looks at this element, right? It looks at 0. The element is actually smaller, right? So you update that to 2, which is, you look at the previous element, you see if that makes sense. If it does, you increment it by 2, right? And then you look at 1, right? And this element is also smaller than 3, which means that if you look at the DP array, you can see that if you include 0, 1, and 3, which was the sub solution for 0 and 1, that makes it a longer increasing sequence. So therefore, you look at DP of 1 and increment that by 1. And the reason why you do that is because 0 and 1 by itself form a long subsequence of 2, and then when you add 3 to that, it becomes a size of 3. So you update your DP to be 3, and then you include 2, right? And 2 looks at 3 and it's like, oh, it's bigger, never mind. It looks at 0, and then it says, oh, hey, wait, hold up, you're actually smaller than me. So it looks at that particular element, right, the DP index, and it just adds 1 to that. So at this point, at least it's greater than what it's seen previously. It looks at 1, and you know what, 1 is smaller than 2, right? So it looks at that index, the same index in the DP array, and it's at 2. So if you add 1 to that, which includes the element 2 itself, then you come to 3, right? And then you look at 0, but it's at 1. So 1 plus 1 doesn't really do anything, so you keep your index at 3. So this is also updated, right? Just your DP array. And then you add the last element. So you look at 2. 2 is actually smaller than 3. So the DP index for that element is 3, so you add one more to that and it becomes 4, right? And then you look at everything else, like most of the elements except 3 are smaller than that. So you look at all of those elements, look at what their value is in the DP array and add 1 to that. But the greatest value here is 3, so if you add 1 to that, it becomes 4. So that your answer is 4, right? Which is the solution that's returned here. So basically, that's how you work with the DP array. I hope that makes sense. If not, let me know in the comments below. But let's use that and write out the solution, right? So the first thing you actually need is the DP array. So let's do new int and nums.length, right? And then what do we need? Oh, we need a max of size 1 because any element by itself can form the longest increasing sequence of size 1. And then you have a for loop. We start with I less than nums.length, increment I, and then you have another for loop that goes through all of the previous elements. So j equals 0, j less than I, j plus plus. So what exactly are you doing? You're saying, hey, go through all of the elements in the array, but for every single element that you see, go through all the previous elements, right? So basically, you start off with 1 here, and there's nothing before that, so you don't really do anything. You start off with 1, you have one previous element, 0, so you go through that. So that way you check if dp of I would be, no, so you're checking, the first thing that you need to check if the actual element, the current element that you're looking at is smaller, right? So nums of j, if it is smaller than nums of I, which means the number that you're looking at in the previously appeared element, if they're smaller than the current element, you need to check if it actually makes sense for to update the value. So if nums of j is greater, so what you'll do is mat.max of the current element itself. So it might have already seen something that's greater, or does the current value plus 1 make sense? So what are you doing there? You're doing the same thing that you did for this or any of the other cases where you updated the number. You're checking, hey, if the number that we're seeing to the left side of the element, if they're smaller, check if you can use that to give us a longer subsequence, right? So if it is, you just update the value, and with that you also update the max value as well. So it would be max and then dp of I. Awesome. And once this is done, you just need to return the max value. Return max. Awesome. I think that's pretty simple. It seems like a simple, like a 5-liner, but to be able to understand this and understand how dynamic programming works, it definitely takes a little bit of time. Let's try compiling this and see if this is okay. Why is this not okay? Nums.length for int I equals 0 unless the number for int j less than j plus plus if dp of I is equal to mat.max or dp of I or dp of j plus 1 max is equal to mat.max of I wonder where I went wrong with this. Oh, you need to fill all of them. I think that's a mistake I made. Yeah, arrays.fill dp, and you fill everything with 1, because otherwise if you do not fill all of that by 1, it's just filled by 0, and it just becomes like 0 plus, like all of this would have started with 0, which doesn't make sense. Okay, so let's try compiling this again. Okay, so the first test case is okay. Everything else is okay as well. Awesome. So let's talk about the space and time complexity of the entire solution. So time complexity of the entire solution is O of n square because we have 2 for loops right here. And the space complexity is O of n since we are using an array to keep a track of the maximum like the longest increasing subsequence for every single index. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I would really appreciate it. Definitely motivates me to make more videos. Thanks so much, and I'll see you all in the next video. Peace.